you get a cosine of sum, I call it cosine minus sine. So it's a cosine first times cosine of second minus, and then we have a sine multiplied by another sine. And it doesn't matter what angles we have, this formula works. So in a case, if you have cosine of angle alpha plus itself, in other words, it's going to be cosine of 2 alpha. Alpha plus alpha is 2 alpha, right? Then I can think of this as a cosine multiplied by cosine, so it's a cosine alpha times cosine another alpha, minus sine alpha times another sine alpha. And that will bring us to the new formula that says that cosine of 2 of these alphas will be a square of cosine minus square of sine. Just like that. So this is my double angle identity with function cosine. Analogously, I could also recall the formula for sine alpha plus beta, which is on the next page in this book. And again, it's sine cosine. So sine alpha cosine beta plus, so it's alpha again, sine cosine, so it's another sine of alpha times cosine of alpha. Please notice that these two terms are the same. It's sine cosine and sine cosine, so I can say there are two of these sines cosines. Let me put sine in the first place. Should be 2 sine cosine, sine alpha, cosine alpha. And we had sine alpha plus sine alpha. And on the other side, it's going to be a sine of 2 alpha. So this formula is going to be if you can't hear me, then you should check if your computer is on mute, because sometimes, in fact, usually that's the case. Someone can't hear me. And, well, sometimes computer gets corrupted, so you need to double check if you may need to reload. That's pretty much all I know in terms of fixing it, because otherwise, if you can't, then there's not much can be done. But usually if you just shut it down, if something is not working or working very slowly, and make sure that mute is off, because that way you can't hear, of course, anything, the volume talking about this little key. So anyways, looks like formula that I just utilized was the one here. And these are so-called double angle identities. And that's what we need to actually use in this section. So I guess I'm going to be dealing with sines and cosines today only, because with tangents, I don't think we encounter very often. So these two formulas, they appear not too often, but every once in a while. So let me try to get, let's say, exercise number 11 here. Actually, I think that's next section. So this is what we did last time already, right? I'm gonna move to the next section because I just produced two formulas that for double angle, that's called section 7.6. So we just need to plug numbers into the formulas as usual. So having formulas is always very helpful. I know some people don't like them because they don't remember them. And I guess you don't have to remember anything. Yeah, if you can't, you just try to restart, because that's all I can say, because that's, I guess, the best way to do. And looks like they want us to practice. And when you practice, the more you see these formulas, the, well, I guess better you get used to them. That's all it is. So how about double angle identities? They want us to use this in, say, exercise number 29. That says, well, I see more of them here in the beginning. So let me start with A and B, and then I can do 29. So exercise 7, I think that'd be better start. With this problem, in the part A, they want to know sine of 2 theta. And all you need is a sine and cosine, because it's 2 sine cosine of this angle theta, but without double. That means that if you have given a sine of theta is 3/5, then you already have first ingredient. Now, how to find the second? How to find cosine? Well, there is a universal formula called Pythagorean theorem, that sum of squares of sine and cosine for whatever angle, doesn't matter, theta, alpha, whatever you put, will be equal to 1. Which means that if I'm looking for the cosine, then I have to bring sine over to the other side, subtract it from 1, that's sine squared, and then extract square root. But then I need to decide if that's a positive or negative. Sometimes people put plus and minus because they trying to show that it be either positive or negative. But sometimes people think that's and plus and minus. No, it's just one of them. And that's the important thing to realize, because if your angle is here in the first quadrant, right, it's in between 0 and pi over 2, so angle theta is someplace here, then we can see that both and sine and cosine will be positive, right? It's number in between 0 and 1, so it is positive, so it's plus, not negative. It could be negative, depends on the quadrant. So the key part is here. They gave us theta because technically, if you are given that sine is 3/5, that's what I should have put here first. Sine is 3/5. That's my y coordinate. There could be another angle that corresponds to it, because it will also have y coordinate equal to 3/5. You see, there are two of them, and that's why they told us that we're here from 0 to pi over 2. So if they give you the angle, then it's pretty nice and straightforward. So what you do is you get a square root from 1 minus this 3/5. So instead of sine, I know what to use, 3/5 squared, right? And then I need to do a little bit of arithmetic inside the square root. So I subtract 9/25. And instead of 1, then I'm going to also use 25. It'd be 25/25. Same numerator, same denominator. I need same 25, so I can nicely subtract these and get 16. But that's great. I can extract the square root you get 4/5. And the key part of this positive 4/5. Because it could have been negative, could have been here, right? So I've got my value of sine is given, it is 3/5. And I also just found the cosine. And that happened to be equal, and we get all of this, and it's 4/5. And this is great because I got the answer. I need to just double this. So denominators give me 25. And I multiply, and numerators is 6 times 4, 24. So we got the result. So when you have both sines and cosines, well, you're pretty much done with all of the exercises, because what you can do is find a tangent and cotangent and all other things. So now part B here, that wants me to use another formula. So in part B, they say, how about cosine of 2 thetas? And for the cosine of 2 thetas, they put in the parentheses. Don't have to put, just in case. I'm going to utilize the other new formula that we just produced. So it's a square of cosine theta minus, I need to use same angle, see if we got here, square of sine of that same angle. So we have both of them. So square of cosine, we just found the cosine, it's 4/5 squared. So it becomes a pretty straightforward little arithmetic exercise, minus sine, which is 3/5, right? Squared. Okay, so I square these, I get 16/25 and 9/25. When I subtract these, I get 7/20. So we got both of those. Well, with these half identities, I'm gonna produce another couple of formulas a little later today. I just want to show you that when you have this double angle story, all exercises are the same. They all go under these little formulas and makes it be straightforward. But of course, you always want to find where these formulas located. And there at the end, remember that big circle that we kept torturing, and they're also next to. Well, let me do another exercise. I'll show it where they're located. So I wanted to look at exercise 29, just to show you that now all problems are going to be pretty much the same. It says find, they decided to use function f of 2 theta, okay, and they say that function f is a sine, okay. So part, it's actually 29, so they say sine of 2 theta. I don't know why they use function f, it's just to make it look longer, but still it's the same formula, 2 sine cosine. And that's a great start. So now I have to figure out about angle theta, which is here. So right now I'm not using this picture, it's for some other exercises when they deal with angle like alpha. So they could have been 2 separate problems, but for some reason they decided to mix it all together. I don't know why, just I guess for fun. So here's the circle. Let me see where the angle 2 thetas is. Angle 2 thetas will probably be someplace here, right? Because it's more than 90 degrees angle. So it's someplace here. I want to say, Alex, are you sure if that's angle theta, looks like it's not very clear. Are we here or two thetas will be here? Because it makes a little bit of a difference, right? If double angle is here or in the other place. How do I figure this out? Well, I guess I'm gonna have to use this point, and that should help me, because they say that x squared plus y squared is 5. Okay. That's the little equation we have here. Circle with radius square root 5, turns out. So x, y is my point on this circle. So I can plug them in. Instead of x, I put a, and instead of y, I put 2, right? And it's equal to 5. So it looks like from here I can find what a is. It's going to be a square root from 5 squared. Actually, I bring 2 squared on the other side, so just 5 minus 2 squared, or 4. So a is square root of 1, which is 1. Okay, that's nice to know. So a is x coordinate is going to be 1. Same place here. And y coordinate is 2. So to be precise, this point is someplace here. When I say, Alex, it's actually a negative number. Notice when you extract square root, it could be positive or it could be negative. So for this case, looks like these would be negative number, right? So I should be aware of this. And now I can make a decision. Look at this. Now it's interesting fact that since half that corresponds to like 45 degrees, right, will be not crossed. What does it mean? Not crossed. Well, the point is a little bit before. So this arc is a little bit before, because the coordinate for y is 2. Remember, if it's exactly half, it's like a square root 2 over 2 and square root 2 over 2. But 1 and 2 is here. So if I used to double this, I would get here, if I doubled like 45 and something. And then if we had this angle, the red one doubled, it's not going to be on the fourth quadrant. It'd be in the quadrant number 3, where both and x and y coordinates are negatives. In other words, my sine is negative and my cosine is also negative. So when I multiply two negatives, I'm going to get positive. Okay. So that's all I have to figure out. Is this a positive or a negative? That's really the key step in all of these exercises. Okay, so what else can I say about these? Well, now I need those sines and cosines, right? So now they want me to actually use the ideas that we're utilizing in the next chapter. How about that? The next chapter is dealing with similar figures that have same exact angles. So what I'm talking about is definition of sine and cosine using unit circle. So in the unit circle, circle radius 1, and if that angle is someplace here that we're concerned with, 2 thetas, right? And the angle theta is here, theta. We need to pull out sine and cosine. That's our goal. But what we are given is a bigger circle, because the radius of the bigger circle, the one that we're actually looking at here, let me make it bigger, has coordinates of this point that corresponds to our angle theta. And these coordinates we already know. So this one is going to be negative 1, right? And that one is positive 2. And the radius of this circle is root of 2. So let me get this as a triangle.
Usted no tenía bloqueada. A mí también me tenía bloqueada.
Yeah.
Pero le llamé, le dije, ¿me tienes bloqueada?
Square root of 2. And we have also 1 here. And we also have 2 here. Please notice that if I have the positive or negative, it doesn't matter. I already figured out that signs are both negatives. I just want to know what on a little triangle. Here will be my X and Y. But for that matter, I use this guy, right? It's little friend. So it's going to be also similar here. Towers. And the key relation is their hypotenuse, because that side is cosine, that's on the x-axis, cosine of angle, and that will be sine. So I can now get this similar triangles running. Again, that's something we do in the next chapter, so I think these problems should have been in the next chapter, but it's fine. We can look at it once, and then when we get to the next chapter, you'll say, oh, we already saw them, so that's great. They're not very hard. Similar triangles. Did you ever see similar triangles? Because we have same angles on them. They called similar. And also, the relationship with corresponding sides stays the same. So if I divide sides of big one by sides of small one that correspond, I will get the same quotient. So big one here is number 1, here's cosine. So I divide big by small. So that's the key idea. I want to keep same proportion, big by small. And this will be the same if I divide 2 and the sine. So they keep the same proportion. That's the point. And from here, I can pull out the actual values for sine and for cosine. So from this first relation, I can say that if I flip both, I get cosine of theta is equal to 1 over square root of 2. And analogously, if I look at the second relationship, this one with that one, I can also flip both of them. So I'm going to have sine over 2 is equal to square root of 2. Oh, wait a second. I flip 1 over cosine, so it has to be not 1 over, it has to be square root of 2, right? Because I'm also flipping. See, need to be very careful. I need to not get over relaxed, but can always fix that. So it's square root of 2. And then now I need to find sine. So from that other relation that I circled. So I flip both of them. It's also square root of 2, but that's my sine over 2, right? So to get actual sine, that brings me to 2 times square root of 2. 2 times square root of 2. That's going to be my sine. So it looks like something like that is what is happening here. So I divide big by small, 1 over cosine. So square root 2 over 1. I wasn't careful. So 1 over cosine is square root 2 over 1. Something is going on with me. So 1 over that, right? Let me see, why is that? Maybe I should stop saving the room. I think that's where it's all coming from. Maybe I should just clear this mess here right now. I can write these formulas again, because I get really stuck in this. So let me rewrite this so you can better see this. So instead of putting them here, I'm going to write this again. So square root 2 over 1 in a bigger format is equal to 1 over cosine So if I flip both, so I get a reciprocal of that, and reciprocal of that is 1 over square root of 2. Okay, I wasn't careful. Same with the second relationship. So second relationship is a square root 2 over 1, again, is equal to 2 over sine. So I'm gonna flip both of them. So I get sine over 2 is equal to 1 over square root. See, if you don't save room, then everything is fine. And I need to, looks like double both sides of this. Right? And this cancels. And that'd be 2 over square root of 2. So it looks like this is something that I came up with. So 2 over square root of 2. And then finally, looks like somebody sent me a message. Did you know that we already moved to the new system in our emails and this Microsoft, whatever it's called. And now one needs to, I guess, log into the emails, not using Gmail, but you can go from AVC ID, just log into all that, and that way you will be able to get in, because I think starting November 1st, you're not going to be able to get into Gmail. So Gmail, if you used to just go on Gmail, is not working starting tomorrow with our college. So what you need is AVC ID if you did not set up that Microsoft account. So once you go to there, then you will be able to find, and it's still called Gmail there for some reason, but it is no longer Gmail, because if you try Gmail, it's not going to accept it. They say maybe it will for sure some period of time while this transition is happening, but eventually it's going to stop to accept it. So I'm talking about Thursday. So if you'd be trying to log in this class, first go into this Gmail, well, you're just not going to be able to go to AVC account, possibly. I hope it's not going to happen, but that's something to watch out. So anyways, let me finish up with that. So it looks like sine was 2 over square root 2, and the cosine was 1 over square root of 2. Now we got something that is gonna cancel a little bit, right? Square roots will cancel, so it's like a 2 or something. So anyways, this is tedious. I don't think these problems we should be worrying about, because they're a little bit too much. In fact, in chapter 3, we're going to get to very details of all that. That's why I'm not sure why this information is provided here for the group of exercises starting 29. But that's fine. You can still work on it. And it's good to try to redo the first exercise I did, number 7. In fact, there were 2 problems, part A and part B. There are 2 exercises. That should be good enough. And now I want to say a few words about another part of this section that actually deals with half angle identities that, first of all, could be produced out of formula that we just had, cosine of 2 theta, which is a cosine squared minus sine squared. And of course, using our old favorite Pythagorean identity. Because from this Pythagorean identity, I can either pull out sine squared, which is 1 minus cosine, or analogously, I can pull out cosine squared, which is going to be 1 minus sine. And after I do this, I can replace this in that formula one after another. So, for example, instead of cosine squared, I can put 1 minus sine squared. So we're gonna keep the rest the way it is. So cosine of double angle is gonna be this minus sine squared. And this gives us a formula, 1 minus 2 sine squared. And analogously, I can produce another formula for cosine of 2 theta, which is going to be 2 cosine squared minus 1. See, so why you, Alex, want to do all these manipulations? Well, because this is going to bring me to the point where I can pull out this square of cosine or square of sine. For example, from this one, I can say that cosine 2 theta plus 1 is equal to 2 cosine squared. And this way I can say that just a cosine of theta will be a cosine of double angle plus 1 over 2, so just isolated cosine squared, but then I extract square root to get the actual cosine. And again, I don't want to put plus and minus here because as we already noticed, it's either positive or negative. It cannot be both at the same time and positive and negative. So it's either or. And analogously, I can also pull out the sine from here. And again, it's going to be either positive or negative inside the square root. And we now gonna have to pull sine. I need to bring it here. So it'll be 1 plus cosine. So I can say cosine theta. And so it'll be plus 1. Oh, from the second. So bring sine, and that'll be 1 minus cosine. I should put 1 minus. It's erasing. It's nice. So I erase 2 theta. Now theta here. That's all. So in square root those erased. So 1 minus cosine of 2 theta divided by 2. So it turns out I think these are good practice exercises to produce formulas compared to what we saw back in the previous section where we had to prove various big looking identities. And I just want to show you where these appear. Are they here? Yeah, so they here, but the actual way they work them out is right there. So double angles. So for example, the relationship with the formulas that I just produced, say the one here and the one with a sine is here. And analogously, the one with cosine squared. But then you extract square root and you get that stuff. And what they did on the next stage, they say, we don't want to use angle theta. We're going to use just half of it. So if you put half here, and since it's different angle, you put like alpha over 2. And this one then be twice alpha over 2, which is just alpha. And that's exactly how they produce those half angle identities. So I went through the process of simplifying things. And I know it is overwhelming with all of these formulas. So I don't want to overload you. I just wanted to show you how they produced, introduce you to them, and then maybe next time we'll practice so you still feel nicely about them. So for example, sine formula. So instead of theta, I put half. See, they put plus minus, but it's always either plus or minus. That's the deceiving part. And we have 1 minus cosine now. Instead of this 2 thetas, they just have alpha, so that'd be half of alpha. And that's the formula. So I guess the key part you need is cosine of double angle, and that's where it's all coming out with use of Pythagorean theorem. So if you start to think about it, it's not too hard. If you plan to go in a calculus classes, you will see definitely more challenging exercises from algebraic perspective. But again, I told you I don't plan to turn this class into a crazy algebraic simplification class, because you can do that and you make problems that nobody's going to solve within a reasonable period of time. And this is not my goal. Well, my goal is to make sense, try to make sense out of this trigonometry stuff, and to just make you believe that this Pythagorean identity that I'm talking about here is really the key formula that is utilized a lot everywhere. So what I can do is maybe one more exercise and then I'll let you go, because it's really getting a little bit too much, right, with these formulas. So say part C, and I can, for a change, try one with, let's say, given something else. Let's say, how about 11, where we're in different quadrant. We're here for a change. So let me do part C. It says find sine of half angle. And for that case, I'm going to need to do this square root thing that we already produced here. And see, square root got erased somehow. So it'll be plus minus, but again, I need to decide if that's a plus or minus. And then I need to get 1 minus cosine of just angle theta. So 2 theta. I use theta instead of theta, I use theta over 2, like half. So let us make a picture of that. Square root 6 over 3. Okay. Square root 6 over 3. And that's our negative square root 6 over of theta. So I put it on the x-axis. When you say, so what do you need, Alex? I don't need anything here because they already gave me cosine. So I can do just plug the numbers in, but not so fast. We're in this quadrant, right? So actual angle is right there, right? That's our one here. So the result is going to be half, and half of it will be somewhere in the positive region. So what I'm doing now is taking a half of that angle. This is what I'm concerned with, theta over 2. So both and sine and cosine of it will be positive. See, that's important because otherwise it could have been negative, because angle could have been here, and divided by 2, you get someplace, and the cosine is going to be negative. So that's why I had to use this circle. So I need to plug things in. So what do I plug in? Instead of cosine, I plug that nice little fraction, which is minus the root of 6 divided by 3. And I subtracted, so the 2 minuses, which is going to be a plus, of course. And there is still 2 patiently waiting. And I'm asking myself, what am I being bothered with here? And of course, this complex fraction. So I multiply by 3 the top and the bottom, right? And I have to distribute that 3 over entire numerator. And at this stage, we'll be done. And that's the good news. So our denominator is nice. It's a 6. And so is our numerator, because 3 cancels, we got a 3 plus square root 6. Yeah, expressions don't look very nice and attractive, but they're exact values. Because if you put this in your calculator, definitely it'd be some kind of decimal, but that's not exact, it's approximate. But we want to exact, so here's the exact for them. I guess next time I should take another look at this, right? Because it's really a little bit unpleasant looking things. But if you have formulas and these formulas are all nicely located at the end, let me go to the end. Those are my favorite pages at the end. So they have all we need really for this class, the trig identities, and you can find them all here and I guess just enjoy, because they all put in the same place and that's convenient. See those are sines of sums difference, those are cosines of sum difference, and these are half angle identities, and where are the double angle? Where are my favorites? 2 sine theta. Maybe I have to scroll up a little bit. Oh no, they're here. They were hiding. This is double angle, and those are 3 that correspond to cosine. And the tangent we'll look at next time. Too much, I think, for today. To the point, they're all nicely gathered at the same place. We're not going to look at these. It's 3-unit class. If it was 4 units, then see, they keep cutting math classes. Now they're trying to turn calculus 1 into 4 units class. If you know, right now it's 5 units, so they're trying to cut and that be 4 unit class. And if it's a 4 unit, definitely cover less material. So that's why we don't do this anymore. But those formulas that I just crossed out, they rarely used in calculus classes. Maybe in the whole book you'll find 1 or 2 exercises that they needed for, and that's why they decided to throw them away. Got a couple of sections, actually the last section of chapter they throw away. And then we're gonna see these laws of sines and cosines in the next chapter. So that's where we're coming to. And I guess that should be enough for you for today. So I'm not going to give a quiz. I'm going to just let you go. I just want to remind you that I updated, I don't know if I told you, I updated on that YouTube channel our lectures from before. So I posted the lectures from previous weeks. So they're all in one place now. So I think it's convenient for you. In fact, the old lectures are disappearing little by little. Remember, our college does not keep recordings on Zoom for too long because it costs nowadays to keep all that. Need to pay that company more. And that's actually the other reason why they changed in this email, because Gmail, if you have account, you probably notice, charges for the storage. So again, to cut the price, so they decided to go with Microsoft because it doesn't seem to charge for the storage as of yet, but who knows, it might start doing it after the New Year's. You never know. So anyways, thank you for being here and for following that. I highly recommend you to look at problems we did today and see if you want to redo them now or over weekend.